at our next transformation. We're going to look at a vertical shift. So we've already noticed what what the a does to a parent function. So remember, our parent function in general is y equals f of x, meaning it could be any, it's a general version saying it can be any one of these guys. If we multiply by some constant a out front, we looked at what that did last time. That stretches it vertically or compresses it vertically, or if a is negative, it will reflect it into the negative values. It'll reflect it over the x-axis. Today we're going to look at what the k is going to do here if we put a plus k out here at the end, and see what that does to the parent function. So that's what I'm describing here. So to do this, we're going to use decimals. You're going to have to recall our parent functions. These are all the different ones we talked about. And choose one for your investigation. You cannot do the same one that I do here in the video. You have to pick a different one. All right, so first of all, what is the default value of k? So if I look at just the k, y equals f of x plus k, the default value would be, what can I make k so that it would still just be the same thing as f of x? So what number would I add onto that that wouldn't change anything? In this case, it would be 0. K would have to be 0 to be the default value. So if I have plus 0, I'm not adding anything on. It's not going to change the function. The default value for a, remember, was 1 because it's multiplication here. And multiplying by 1 doesn't change anything. So since this is addition, adding 0 does not change anything. So the default value for k is 0. So now you're going to go to decimals and you're going to input your parent function. I'm going to use sine of x. You cannot use that one. All right, so there's sine of x. I'll give you a minute to put yours in there, or you can pause the video and do that. You got to pick one of the other ones. Okay. Next, you want to input your transformation statement here and look at that graph. So it's going to be y equals a times f of x plus k. And they want us to add a slider. We're going to add a slider for all of these. It says make sure that the constants a and k are set to their default value. So since a is being multiplied, when you multiply by 1, nothing changes. So a is going to be 1. But k, we're adding k on. So default value, if we add 0, that doesn't change anything. So I'm going to drag and put k to 0. Being a little laggy there. And you can see that the two graphs match each other, right? If I turn off the black one and turn off the red one, they're in the same spot, right? Okay. So we are all set up here. Now, keep in mind what this means here. This f of x, it really means that we have like a sine of x plus k. I want to show you that. This f of x is just in general, and it's replacing it with sine because I say it's equal to it. But it's the same thing if I just put sine of x in here. Okay, so it's that same function there. But I like to just put f of x in there. I'll show you why in a second. If we leave it as f of x, that means we can change our f of x, our parent function up here, to anything we want. It was sine, but what now? What if I make it x squared? Well, there, if it's just x, right? I can see that I can play with my transformations here. I don't have to go change it everywhere. I can make it an x squared. And it automatically changes both functions. So that's why I like to have the f of x here. It just changes everything. All I do is change my original f, and it also changes it in my transformation statement down here. All right, so you can choose any parent function you like. As I said, I'm going to go with sine of x. You're not allowed to use sine of x. All right, my a default value is 1. I can go in here and just type it if I like. and say a equals 1. It looks like the sliders want to, things being buggy. Try again. If a is just 1, it wants to know what I want to go from. I'll say negative 10 to 10. You shouldn't have to do this. I don't know why my thing's freaking out. I'm not going to put a step in there. It could be anything. And then our k equals 0. I'll go from negative 10 to 10. Alright, so there we go. Alright, so my constants are set to their default values like it says. The two graphs overlap. So they want me to start by increasing the constant k. So let's investigate what that does. If I make it's currently 0, I'm going to increase it and make it larger. What does that do to the graph as I make it larger? It looks like it's shifting or sliding shifting or sliding the graph upward. Now let's decrease the constant k from its default value. So let's put it back at its default value, which was 0. And now let's decrease it, make it negative. It looks like it shifts the graph or slides the graph down. Sliding or shifting. Alright, so now we want to change the parent function. I want to put this back at its default. Change the parent function to one of the other choices from the beginning. Manipulate the constant k and observe the behavior of the function. Does k exhibit the same effect? So the question is going to be, if I look at a different parent function, is it still going to do the same thing when I mess around with k? So let's look at, you pick a different function than me. I'm going to pick the square root of x. You try something else. So there's my square root of x with all my default values in. We should recognize by now that that is the parent function of the square root of x. If I take k and I increase the value of k, it looks like it's shifting that function upwards because I'm just adding a number on to it. And if I decrease it past, go lower than the default value, it looks like it shifts it downward. So it seems to be yes. It shifts the graph upwards or downwards. Do I think it'll have this effect on any parent function? Yes, it should. So adding a constant at the end should shift the thing up or down. Can you summarize this effect? I kind of just said it. And make a rule. That I will leave up to you. We will discuss that at the start of class. Can you make a rule? So, sorry, I was writing in here and you weren't able to see it. I forgot to switch over. But this is what I said here. When we increase the constant k, what do we see happening to the parent function? We see that the graph is sliding or shifting upward. When I decrease k lower than the default value, we see that the graph slides or shifts downward. And then do we expect that when we change it? Yeah, it still shifts the graph. If I change my parent function, it still has the same effect, shifting the graph upwards and downwards. And do I think it'll have this effect on any parent function? I say yes, I think it would. And in terms of making a rule, you want to make a specific rule. What is the default value? If you go bigger than the default value, what does that do? If you go less, what does that do? So we want to make that rule, and we'll talk about it in class.